So we've seen how to graph a line when it's in point-slope form. However, lines can be represented in many different ways, and their equations can often look very different from one another, even though they all end up being equations that represent lines. So here we have an example of an equation. Its graph turns out to be a line, but a student who's not familiar with it may not know that. And so one thing to think about is, how can we get students to understand that the graph of this equation is also going to be a line? And then as they get more fluency with these type of equations, can they start to recognize key features of that line that they can sort of extract immediately just by looking at the form? One basic principle we want students to understand is that the graph of an equation is all the points that make the equation true. And so with that in mind, we encourage students to, when they're not familiar with what an equation represents in terms of its graph, to make a table. And by making a table, we want them to actually come up with points that would make this equation true. Now, as an educator, you run into a few problems. One is, for students who have sort of weaker number sense skills, they have to be pretty good at deciding which numbers to plug in for x and or y. So for instance, plugging in 1 for x is often a good choice. However, in this case, it's kind of not, because if you plug in 1 for x, you end up getting 1/3 times 1, which is 1/3, minus 4, which is -3 2/3. A very strange number to plot on a graph. So that is one issue teachers run into when they're teaching students. However, we try to get them to at least understand that there is one x value that you can plug in that is very convenient because it tends to make values go away when you multiply by them. And that is, that number is 0. So by plugging in 0 for x, we can see that the y value that we'd have to write down to make this equation true is, well, let's see, 1/3 times 0, 1/3 times 0 minus 4 reduces to y equals -4, since 1/3 times 0 is 0. So now we know a point on this graph. The point 0, -4 makes this equation true. So we have a point. Now again, if a student's unfamiliar with this equation, or the form of this equation, they would have to get at least one more point to be able to graph it. Technically, we want them to get 2 more points, because you really need 3 points on a graph to really know for sure that you have a line and not some other type of graph. However, as I said, once students get familiar with seeing these forms of representing a line, we sort of allow them to use their memory of these forms to graph the lines more quickly. But let's say we just want to get a few more points because this is the first time a student has seen this. Then we'd want to encourage them to plug in numbers that are easily divisible by 3, since we're going to be multiplying that x-coordinate by 1/3. So another point to plug in that would result in a nice whole number is 3. And so now we see that 1/3 times 3 minus 4 would simplify to, well, 1/3 times 3 is just 1. 1 minus 4 is -3. So when x is 3, y needs to be -3 in order to make that equation true. And another good choice for x would be 6. So when x is 6, then we get that y equals 1/3 times 6 minus 4, which is equal to 1/3 times 6 is the same as 6 divided by 3, and that's a 2 minus a 4, which is a -2. And so watch what happens when we graph these points. So 0, -4 would be here. 3, -3 would be here. And 6, -2 would be here. And so we can see a couple things. One is that indeed we have a line, right? We don't have like a parabola or any other kind of weird graph, because these 3 points are all what are called collinear, right? The slope between them is the same. But there's another thing that students may notice. One is that because we know that to move from one point to the other, you need to go up 1 and right 3, we can get more points without having to go back to this table here. So we use the fact that the slope between 2 points on a line is constant to get more points. Now again, as students get more comfortable with this, what they'll start to notice is, well, I've seen the form of this equation so many times, and I'm starting to recognize that the slope is a third on this line, and what do you know, the number in front of this x here is also a third. And they start to recognize that that's not a coincidence. So in fact, when you see an equation written in this form, you know that it's a line and that its slope is 1/3. And so the only thing you need now, if you want to graph it, is you need a point. And getting a point isn't so bad, even if there's fractions, even if the slope is a fraction, because by plugging in 0, you can get that point to start at, and then you can just use the slope to get more points. So, as students progress, we sort of let them get 1 point, which often is one that has the x-coordinate of 0 and a y-coordinate of -4. We have them recognize the slope, and we have them graph the point and use the slope to get more points. An equation that's written in this form is called slope-intercept, because it gives you the slope, but it also gives you what's called the y-intercept. The y-intercept is simply where the graph intersects the y-axis. So you see that -4 that I'm going to circle in green is the y-intercept of this graph. Okay, but if students forget all that, they can still get the graph of this line by going back to our basic principles of making a table and plugging in values and determining points that would make the equation true. Again, keeping in mind that some students are weaker or better than others at deciding which x values to plug in to ensure that our outputs or our y values are nice whole numbers.